cube notation with different types of Rubik's puzzles like the pyramids and 4x4, and I'm also going to be teaching you about like what is cube notation, and I'm also going to be teaching you parts of the Rubik's puzzles that I have today. So first of all, I want to tell you what cube notation is. So cube notation is a bit of a code for Rubik's cubes, a code to tell you which way to turn it. And with that being said, what do we call cube notation's turns? We call that an algorithm. So for example, right, up, right prime, that is an algorithm. So that is what cube notation is. So for example, there is L for, and that L stands for left. So this is the left side of the cube, and since it's the left side of the cube, you turn to the left, and on the left, you turn it clockwise. So this is clockwise, and then you just turn it clockwise. Then when you turn back here, so this is clockwise, you turn back here, so this is an L move. And when you see an L with an apostrophe right after it, it means, we call that an L prime. So an L prime means you do it counterclockwise or anti-clockwise, whatever you want to call it. So anti-clockwise is basically just turning it the opposite way. So if this is L, that means this is L prime. That actually goes for the same with right, except since this is L, you go down. But right, you go up, because when you look over here, this is clockwise. So left you go down, right you go up. And R prime means you go down. So another example is up, U. U is basically the same thing. So this is up, since you see that is clockwise, so that is up. And this is up prime. Up and up prime. So the next thing is down, D. So down, you actually move it with your pinky. You might need a bit of practice at first, but you'll get it eventually. So D is actually this. So this is D. So this is D. Because when we look here, that is clockwise. So this is up, and this is D. Another example is F for front. So front is this. This is a bit easier because you don't exactly need to make sure that it is counterclockwise or clockwise, because you can just see this is clockwise, anti-clockwise. So F prime. And you might think like, what is the difference? I mean, it's still white in front. Well, in my case it's black. It's just because I have a really weird cube. But why is it? How does it make a difference? Well, if you look to the sides of the cube, this is different. So there we have it. Now another example is back. So this is front, and then back is that. So back, then B prime. Because if we look at the back here, this is back. See? So that is back and B prime. So So another thing is, if you see, for example, down, but it says it's followed with the number 2. It doesn't have a apostrophe. It doesn't have an apostrophe, and it's not alone. It has a number 2 next to it. So what you need to do if you have a case like that, you spin it 2 times. 1, 2. Now it doesn't really matter which way you turn it, because if we do down prime 2, it's basically that. So there's white on the front and yellow at the bottom. And if we do down 2, it's basically the same thing. No difference at all whatsoever. The whole cube stays the same, so you can actually do that whichever way you really want. Okay, so that was a 3x3 cube notation. Now we'll move on to the next puzzle. Oh, and by the way, there are other types of things like M moves, which are like this, but I won't exactly tell you in this video, but I will tell you about them when we need to use M moves in another video. Okay, so now this is the Pyraminx puzzle. So this is the Pyraminx puzzle, and it works basically the same as the 3x3. So there's ups, rights, and lefts and all that. So, but this time, you can't really do a U2 or an any 2. But you can, but like, you can do it a shorter way. So U2, and that has green at the top and blue at the bottom. But if we do U prime, it'll basically be the same thing. So you might not find any 2s anywhere. So here, this, you might think that this is right, but this isn't right. This is right. This is left. This is back. And as I said before, this is up. So another thing is, you can't really do fronts and downs. I mean, you can, but it's not really common because it's just really hard to do it. It's quite uncomfortable as well. And downs, you can't really do it. It's kind of hard. So that's that. And the tips. You don't really need to learn an algorithm for the tips. I mean, the corners, like, you can call them the corners, but they're really just the tips. So you don't really need an algorithm to do this. You can just like figure it out yourself. So like, you do that, and there it is. So there we go. So now we have a 4x4, and as you can see, it's very different with the 3x3. It's a lot harder as well. It's not too hard, but like, it just takes longer time. So here there's 3 and here there's 4. I didn't have to explain that. But anyways, the 4x4 is a little different. I mean, everything else is basically the same. Like all rights and lefts and downs as well. But this time it has more layers. So this is some more cube notations with the 4x4. So on the 4x4, you can find a letter, like for example up, but it is followed with the letter W. Now, if there's a W, you move 2 layers. So you move 2 layers. You don't move 1 layer, you move 2 layers. And another case is if it is followed with a W and the number 3, you don't do this 3 times, because that's we don't really do that. But you actually do 2 3s like that. I mean, we can do downs, yes, but sometimes we just find that. So yeah, that's really it for the 4x4. Now we have the 2x2. So the 2x2 is It looks pretty easy, but you can get pretty confused with the algorithm. So sometimes if there are backs, B's, you think like you can do a B2, for example. It's pretty hard to do B's, so you decide to do fronts instead. So you see if there is a B2, we've got that, and this is at the top, so red is at the top and orange is at the bottom. But if we do fronts, orange is at the top and red is at the bottom. So you can get the algorithms wrong. So it's just a little warning, just in case you think that, like, you thought that it's going to turn out the same. So yeah, that's really it for the 2x2. Next up is the Fisher cube. Now the Fisher cube is quite weird how it turns. You actually don't turn it like this, because you can't exactly turn it like that. You can do this, but you can't really turn it like that. So what you do, you don't face the flat part. You face this part. So here, it's just up, right, down. God, this Fisher cube's not too good. But yeah, and then this is front and back and all that other stuff. This one's really easy. It's basically the 3x3. I mean, it's got 3 and 3, but it's a mirror cube. So what you do is basically the same as the 3x3. There's no difference, but the difference is only it just shape shifts. So you can do right, up, right prime, and it's basically the same moves. Just thought I would tell you just in case you got confused. And this is the 2x2 mirror cube. Again, same as the normal 2x2. Yeah. That's really it for the cube notation. So this is a little bit about like what parts of the Rubik's cubes there are. So for the 3x3, this each face has one center, and that one center can't move. So like yellow is always opposite to white or black, red is always opposite to orange, and green is always opposite to blue. And no matter what, you can't really change the shape. Like, you can't really change the centers. Like, there's no possible way to put this next to the green. It's always opposite. So those are the centers, and the centers can't move. And these are the corners. The corners hold 3 stickers, and the corners can move places. So yeah, and these are the edges. They hold 2 stickers, and they can move as well. So this is the pyraminx again, and the pyraminx is basically the same as the 3x3. It has corners, centers, and edges, but the edges, they're kind of a bit weird, but we sometimes call them tips instead of corners. So these are the edges, and these 3 that are close to the corners, they are the centers, so they actually can move. So they can split up. So you will have to make sure that all the centers are the right color. So yeah, they can move, unlike the 3x3. So that's really basically just it. So yeah. So the 4x4 has a lot of different things. So the corners are the same, but there are two edges. Now, if you swap the edges, you can swap the edges, but it will be solved. There's no big deal about that, but you can get them mixed up sometimes. And then these are the centers. So unlike the 3x3 again, the centers can move places just like that, and but the centers actually can be next to the green one, like blue and green can be next to each other. You can just adjust it and then they'll be next to each other, full centers. So yeah, that's really just the same thing. There are 4 center pieces here and 2 edge pieces. That's really just the difference. And the Fisher cube is a really weird one. So in like this, since this looks like a corner because it has 3 stickers, it looks like a corner, but it's actually an edge. These are the corners. And these are the centers. So these are the centers, these are the edges, and the ones with no, the ones that looks like centers, they are edges. So there are 2 types of edges, the ones that hold 3 stickers and the ones that hold 1 sticker. And the corners, they really just look the same. They have two stickers, and that's it. And again, this one right here, this one is a center. Oh, no, wait. This one, okay, so this one is a center because these are centers, and these, that means they're centers as well. So yeah, 2x2 is filled of centers. Corners. There are no edges, no centers, only corners. So that's just that, and I won't be explaining the 3x3 mirror cube and the 2x2 mirror cube because they're basically the same thing as these two. All have the same parts. So yeah, that's it. So that's all for this video. I hope you found it useful, and I'll see you all next time. Bye.